Assalamualaikum everyone, you are watching Science with Asan Badun. So this is our next part of the video. The diagram shows an electric circuit used to determine the brightness of the light in a room. Here we can see a circuit where there are two cells or a battery, a light dependent resistor and a regular resistor. So the question says, add a voltmeter to the diagram to measure the voltage of resistor R. So since we are measuring the voltage against resistor R, so we need to draw a voltmeter over here parallel to resistor R. So the symbol for voltmeter is a circle with a capital V, and always we need to connect the voltmeter in a parallel circuit. Okay, then so let's move on to the next question. State the formula linking voltage, current and resistance. We know voltage equals to current into resistance, so V equals to IR. So you can write down the formula here. The voltage across the resistor R is 1.9 volt. The resistance of the resistor R is 800 ohm. Calculate the current in circuit. Give your answer in milliamps. Okay. So here is the unit, which units are given in SI units. So first write the formula. V equals to IR. So we are calculating the current. So current can be subjected. So the formula will be V by R. The voltage here is given 1.9 volt across R, and the resistance of R is 800 ohm. So the answer we will get is 1.9 divided by 800, which should give us 0.0024 ampere. So the question asked about milliamperes. We need to multiply it with 1000 to get milliampere. So that should be 2.4 milliampere. Okay, so answer is 2.4. Okay, in C part it says, explain why the voltage across the light dependent resistor decreases if the brightness of the light in the room increases. This is very conceptual question. First, let's understand the question. Explain why the voltage across the light dependent resistor LDR decreases if the brightness of the light in the room increases. So voltage across the LDR decreases if the brightness of the light increases. Okay. So we know that how LDR works. When the brightness of the light increases, or the light which we were showing in the room increases, the resistance of the LDR decreases. So the current increases. So let's write it down first. As the brightness increases, the resistance in the LDR decreases, so current increases. As the current increases, the voltage of the fixed resistor also gets increased. Voltage of the fixed resistor increases, and since the voltage of the fixed resistor increases, the battery is giving a fixed amount of PD or fixed amount of voltage, or the voltage in the battery is also known as EMF. The total voltage of the battery does not change. So if the voltage across the resistor increases, so the voltage across the LDR should decrease since they are connected in series circuit. The total voltage of the battery does not change. So, and since they are connected in series, circuit, so the voltage across LDR should decrease. So this is our answer for 4 marks. Okay, number D says another resistor is connected in parallel with resistor R. The new resistor has a higher resistance than resistor R. Explain what happens to the current in the LDR in the circuit diagram, assuming that the brightness of the light in the room remains constant. Okay, so let's first understand what happens if we connect a resistor in parallel. Okay, so we know that in parallel circuits, if we connect 2 resistors, the total resistance is halved, or we can say that total resistance decreases. Okay, so increasing the number of resistors in parallel decreases the total resistance, and we know that current is inversely proportional to resistance. So if resistance decreases, current should increase. Okay, so thanks for watching our video. Please subscribe our channel for more videos like this. Thank you.